Hey, brothers and sisters from the Starknet ecosystem. Welcome back to the Stark Cafe. This is Nurstar speaking, your personal Stark barista. And once again, we are ready to delight you with some very special Starknet content. So guys, it's time to continue our exploration through the great chain infrastructure work that the Nethermind team has been doing on the Starknet scaling solution. Yesterday, on the first episode of this ongoing NethermindStark week at the Stark Cafe, the co-CTO of Nethermind, Yorick, guided us through the overall approach and mindset that Nethermind used to start dealing with Starknet and with its programming language, Cairo. Furthermore, we began talking on the surface about the different tools and services that they've been building and offering so far on Starknet. Among them, there is Juno, a Starknet full client, which is set to play a crucial role in decentralizing the Starknet network. Well, in today's session, we're going to go deep on this client. And in order to celebrate its latest upgrade that was announced just yesterday, our beloved Yorick is coming back, but this time in very good company, as we'll also have the pleasure to host Omer and Anek, who have been working very hard on Juno and on its latest version. So let's welcome this dream trio. Hello, Yorick, Homer, and Anek. Welcome to the Stark Cafe.
Thank you, Nurstar. Thank you for having us.
Yeah, hi. It's good to be here.
Good to be back.
Yeah, it's nice to have you back, Yorick, and welcome to Omer and Anek. I'm very glad to have you here, the Stark Cafe. Really excited about this second episode of our Nethermind Stark Week. But let's seeing that yesterday we had a very nice overview and we spoke a lot generally about the different tools that Nethermind is building on Starknet. So this time we can afford to go straight to the matter of to the topic of the episode, which is Juno. So I'd like to ask to start asking Anek for a question. So let's start with what is Juno and what role does the Juno Starknet full client play and feel in the Starknet ecosystem?
Sure. Hi. So Juno is a Starknet full node client, which has been written in Go. Its intended purpose is to be the first point of contact with the Starknet ecosystem. It provides permissionless access to Starknet and verifies its data. While Juno's long-term goal is to decentralize Starknet away from feeder gateways dependency, and we intend to do that by becoming a sequencer and taking part in consensus to secure the network. We have been actively taking part in designing the P2P protocol and reviewing the decentralized architecture of Starknet.
To add to that, for the listeners here, the feeder gateway is the gateway that's run by the Starkware team. And this is basically how everyone interacts with the Starknet ecosystem now. It's one centralized server which runs all of the logic for how Starknet works. And the immediate roadmap for this is to improve the performance, which I hope all of you have been checking the numbers on Gwirly 2 today. They are incredibly exciting. I think we're hitting 35, 40 TPS, which is crazy. Finally glad we can talk about these things publicly. In the future, we'll be moving away from this centralized model. We'll talk about that later.
Homer, would you like to add something on what Yorick and Anek said?
No, I think they covered everything pretty much.
Very good. So first of all, congratulations, for the latest version of the Starknet full client Juno. If I remember well, the version at 0.4.0. And also I saw that you performed different tests during the last week, leading to this upgrade, and they went all very good. So I saw that the full client was very, very fast. And furthermore, we all know that Starknet uses proofs to prove transactions. So my question is, do we even need to decentralize Starknet even further? Or even though we already have this kind of protection that the proofs serve?
That's a good question. But thank you so much for the well wishes around 0.4. It was a really big deal for us because it's the first production ready version of Juno. So if you're running anything with Starknet infrastructure, you want access to the data permissionlessly. Maybe prematurely to use that word on these nodes, but it should be able to handle a lot of what you need. We'll get into the use cases of Juno later in this talk, but do check it out. Check out the tweet and have a look at the release notes. They're quite comprehensive. Yeah, so it's a great question on whether or not ZK proofs are enough for a blockchain, and whether we should actually decentralize. Of course we must, but I'll get into the reasons why. The first thing we need to answer is what does ZK provide? And ZK provides you with one security property, which is integrity of computation. So the idea here is that I can run any amount of computation, and I can give you a proof that I did it correctly, and you can check that I did so in a very short amount of time. So the way this works in Starknet is that the Starknet sequencer runs a bunch of transactions, and then it proves with Ethereum that it has done these computations correctly. So it's actually borrowing Ethereum security and saying Ethereum verifies that everything that I've done is honest, which is really nice. It can also be used to provide privacy, but this is not used in Starknet specifically. I think it was used in Zcash and a few other things. I believe Starkware used to play with the idea of including it somehow, but I'm not sure where that went. In that kind of example, it would be okay, user X transferred some amount to this other person, and it wouldn't reveal who the user was that transferred the amount or even the amount. It would just verify that that transaction took place. And you could reveal arbitrary subsets of this information, which is really, really nice. But what's missing from this picture, right? What do you expect from a blockchain? What are the security properties? And the first security property you could probably think is immutability, right? I don't want someone to be able to change my balance on the blockchain unless I say that I'm changing my balance. And in this case, we don't need to decentralize because the ZK proof actually gives this to us in the form that Ethereum says what the head of Starknet is. And it says, I will not update the state unless you give me a ZK proof of a valid transition from the state to a new thing. So we don't actually need to decentralize for that one either. So Starknet's got immutability, it's got integrity. Now we get into questions okay, fine, no one can touch my data, but I want to always be able to access my data, or I always want to be able to use it. I would actually like to be able to pay for something on Friday morning when I wake up, right? And not have to worry about everything going offline. So on this front, we need decentralization. Well, we need decentralization and probably an escape hash, but I'm not going to get into that detail. In decentralization context here, you say that there are many nodes that are running the network, and one of them is responsible for creating the new block. But if this proposed block builder goes offline, someone else can take over and still propose a new block. So we need decentralization for liveness. Now, this is a property that will come much later in the Starknet ecosystem, and we're working our way up to this point. The last property that you probably want is censorship resistance, saying okay, cool, the nodes are up, I can always interact with the blockchain, but how do I know that I'm not being targeted specifically and having my transactions either altered or removed? And this is two separate points. In the altered form, the ZK proofs actually prove that you signed the transactions correctly, so no sequencer can lie about what you said. But being omitted is impossible to prove. Now, there are a few techniques that Ethereum are looking at, inclusion lists and a few other things. And if you want to talk about that, I think Swapnel's in the audience here. You can message him. But in the meantime, the best way to get around this is having decentralization that works, and that you have nodes which are not malicious that you can speak to and have your transaction included eventually, right? Even if some of them are, say, OFAC compliant, as in the Ethereum world, right? those are the reasons you want to decentralize, but Starknet makes it kind of more interesting because it still borrows more from Ethereum. For example, the set of nodes that's doing the validation could be managed by Ethereum, so that's no longer a security property of Starknet, and you can rely up to Ethereum security. And things like bridging between messages of L1 and L2, some bridges would make sure that all the nodes come to consensus, but in Starknet, you can verify that an L1 message, a message from Ethereum to Starknet, is absolutely correct because when it's verifying the proof, it checks that all of the messages that have been consumed from Ethereum are actually correct. So you kind of have this really cool place where you can experiment with the decentralization and how you take this while relying that certain security properties are actually being handled by Ethereum. So you can you have much more room to play with what your decentralization gives you over, say, Ethereum that has to make sure that all of these properties are provided by one algorithm, basically, or well, a combination of algorithms that are tightly operated. So we're kind of abstracting away some of these things. We're gaining a bunch of security properties, but we still need the others, and we need to make up for that with decentralization.
Awesome, Yorick. I mean, I learned a lot from this explanation about the additional properties that a full client would bring, in this case, on Starknet. So ZK proofs are not enough, as far as understood. And obviously, we need to apply an additional layer of decentralization on Starknet. Also, taking the good from the L1 and the security, obviously the security protection of Ethereum. And we also I also know that there are some devices like the one developed by Khazar Labs, which is called the plug and play Starknet node. Starknet device, sorry, which is basically a device that lets you run your client, and there's also compatibility with Juno, as far as I remember. So I also saw there are also different other full nodes. For the time being, there's, if I remember well, Papyrus, right, developed by Starkware, which is the least used as far as I remember, and which is seen as a positive thing by the Starkware team as well. And well, I wanted to know, what Juno's features make it different from the other full nodes, and also what kind of design choices did you make in order to make it stand out of the others full clients?
I think I can take that one. First of all, shout out to Kezo Labs for their awesome work. And thank you for the chance to boast about our client. So probably the biggest one is our database layout. The biggest contributing factor to storage requirements of a full node is the state storage. In Starknet, state is stored as a binary, Patricia Merkle trie. So it sounds fancy, but it's essentially a data structure that allows a full node to verify the integrity of the internal state that it has in storage against what the sequencer provides as the state root. There are a couple of alternative approaches in how you can go about storing a trie in storage, in a persistent storage. The simplest approach is storing the nodes in the trie by their hash. By their hash, I mean the essentially summary of the node's internal data. This allows you to store identical nodes only once in the storage, since the trie can have identical nodes. And the hash-based trie provides historical state implicitly with little to no additional logic implemented. But the biggest downside about it is as the state progresses, you end up with trie nodes in storage that are actually not part of any version of the state trie. So these what we call are orphan nodes. Unless you actively look for these orphan nodes and prune them, delete them from the storage requirements of the nodes will grow really fast. So the alternative that Juno decided to implement is a path-based trie. So instead of storing trie nodes by their hash, essentially by their content, you store them by their path, which is the position of the node in the trie. This provides implicit pruning since nodes are updated in place. So the storage requirements go way down. So even a node like a small single board computer node that Starknet is, you are able to store the entire state trie. So with this approach, you end up needing a separate storage for historical values, but that is like pretty lean compared to a hash-based trie with no pruning in terms of the size, the storage requirements. One other benefit of a path-based trie is that it is really efficient for lookups for reading, which is done pretty frequently when executing a contract. So contract execution should be comparably faster to a hash-based trie implementation. One other field that we currently have an edge over other full nodes is that we have completed the integration with the new Rust VM, which is what is the core of the O12 upgrade. It is expected to be like multiple times faster than the original Python VM. So any RPC request related to contract execution, like Starknet call, Starknet estimate fee, should be a lot faster on Juno. So if you're looking for that O12 snappiness in your full node, Juno is the only option right now.
Very good, Homer. It was quite fun to hear about the design that you've been shaping the Juno full client with. And, however, I suppose that it wasn't that fun, developing it, because I suppose that it is a very hard job. So my question is, what is the areas bug and also the difficulties that you encountered by building Juno?
So it's like definitely hard, but being a different kind of broken, I enjoy it actually. And about bugs, like from the top of my head, I can't think of a cool bug right now. But since this was fairly recent, I can briefly talk about a challenging feature that we had to implement. So Juno is written in Go, which we all love, but the entire Starknet open source ecosystem is built around Rust. So it is really easy for other projects in the ecosystem to integrate with each other, but for us, the situation is quite different. For foreign function interfacing, FFI, most of the languages have pretty good support for C. So if you want to integrate two other languages that like has no native support for each other, most of the time you end up having to communicate them through a C API. For the Rust VM integration, for the Blockifier integration, that's what we have done as well. So Go can export its functions as C symbols, and it has this feature called CGo that allows Go side to call C code, and Rust can do just the same. So we had to expose C symbols from both Rust and Go that wrap our actual logic and had to link them all together at the end. Since O12 and Blockifier and the Rust VM has been a moving target for so long, it took a while to get it right.
That said, the Rust rewrite has been an absolutely incredible effort from Madame the Class side, along with Starkware, and we're very happy to see it in 1.12. And I think that one of the big tickets on Nethermind side is to start replacing all of the REST implementations with Go versions to diversify the stack, so that like a bug in one doesn't cause the whole network to topple over. So that's a big part of our roadmap in the future. I believe Lambda Class has already started a Cairo VM in Go, and we'll either be aping in with them or we'll be making a competing one, but competing in the absolute friendliest sense. So we're very, very excited to be working on this in the near future.
Amazing, Yuri.
Just to mention about the bugs that you were asking for, I remember in the early days when you were implementing the try, that one of the things in adding a leaf to the try when you're syncing the state diff has a value of 0, and inherently the value of 0 means to delete the node in the try, but we remember that we couldn't figure that out because we just expected to add the value, and we didn't really understand why our state roots were not matching. So we kind of had to get other nodes developers to help us out to understand why that was happening, and then it became a really quick fix, and then suddenly everything started working.
Yeah, definitely collaboration between all the client teams are insane. We're constantly in touch with them.
Awesome, guys. It's very nice to hear that despite the difficulties that you encountered by building such a difficult piece of infrastructure like a node, you managed to get the best out of it. And I also believe that that stimulated your dev talent a lot. So I think you will bring it with you as a very precious experience. However, let's involve our listeners a bit. And for those of you guys who were wondering whether we can get more technical than this, the answer is yes. But before doing so, I would like to shout out to some of you who decided to come and listen to us live. So hello to Thomas, Exodus, Chris, Fabio Catalao, Chi, C Colorado, Shoigo, Beja, Julio, Anneli from the Nethermind team, who helped us a lot in planning this NethermindStark week and this episode as well. Then shout out to Julio, Kodawari, Swapnil, Ether.fm, Kobur, Bazat, Crypto Ninja, and all the others. And well, let's start with the very technical part of this episode, and we'll go back to Homer again. And I saw tweets about Juno's performance recently, and they were very positive, by the way. And I would like to know into details. How long does it take Juno to download all the blocks?
Thanks. Those numbers that we shared are actually outdated now. So on the latest release version of Juno, it takes around 2 days to fully sync to mainnet. And per our latest runs, I think around 3 days to sync to girly testnet. Those numbers may sound quite a lot, but considering that this is the full sync mode where we are like processing each block one by one, it is pretty good with definitely more room for improvements. And thanks to the flat DB layout that I just described, our storage requirements are pretty low as well for archive mode operation, where we essentially retain the entire history of the state. For mainnet, our DB takes, if I'm not mistaken, a little less than 30 gigabytes, and for the girly testnet, it takes around just over 32 gigabytes. For performance improvements, we try to follow a benchmark and profiling centric approach. So once you figure out what the hotspots are in your sync process or anywhere else in this matter, it just becomes a matter of time before you find a way to just make it go faster. Sync process is fairly computationally heavy, mainly due to the state commitment calculation. So block process, like block import process, does a bunch of try operations and a whole lot more hash operations just to be able to calculate the state commitment. So we try to make good use of the concurrency facilities that Go is providing us. Figuring out what can be done in parallel during the sync is the hardest part here, actually. The most recent improvements that I just mentioned were actually a result of being able to make a part of our block import logic run in parallel.
Great numbers and impressive stats about the latest version of the Juno Starknet client. And I also would like to speak to Anek a bit. So, I understand that the work on decentralization is still ongoing. So you'll improve the Juno client a lot in the future. And but I wanted to know, what can I do if I want to run a node today? And what will I be able to do?
Sure. Hi. So once you have gotten your Juno node up and running and you're fully, even before you're synced, and during sync, you can access all the RPC calls that we have implemented according to the Starknet spec. You can simulate your contract calls. You can estimate fee for any transactions that you want to deploy on the mainnet. You can even we added calls for you to even submit transactions through Judo, and you can get the status of your transaction from Juno. So it is getting to a point where you don't need to use a feeder gateway at all, and soon we will have the Trace API implemented, whereby everything for the RPC would be implemented, and you would not have to worry about having to interact with the feeder gateway and the gateway to submit and get information, submit transactions and get blocks or transaction statuses or whatever information that you require. Apart from that, we also created direct access to our DB. So through gRPC, any indexer can get access to our DB and perform any indexing that they require into their own data structures, which are efficient for them. And this allows Juno to be one of the clients which allows very fast indexing. And as we mentioned before, Starknet nodes have been running Juno using using their nodes to catch up, to present stuff. Sorry, to present Starknet data. Apart from that, we have Voyager and StarkScan, who can use Juno to serve as explorers. And yeah, a lot of exciting things can be done using Juno. Almost anything that you require to access Starknet Juno can be used for that.
Very well, Ned. Thanks a lot for that. And as we are moving towards the end of the second episode of the NethermindStark Week, I would like to tell our listeners that if they would like to ask the guests for a question about the Juno client, feel free to either write a question on the comment of the space, or just by sending us a request to speak, and I'll be glad to approve it. By the way, right now, could I also know, what does it mean to we've been speaking a lot about decentralization, but what does it mean to decentralize a network through a client? And also, what does it involve? And so far, how does Starknet work right now?
Sure. I'll describe how it works right now and what the next steps are. So right now, as we have already mentioned, that there is a single sequencer which is accessed through the feeder gateway, and that is completely responsible for creating blocks. And also there's a prover which submits the proof to L1. So as Jörg mentioned earlier in the call, the need for decentralizations to move away from single point of failure, censorship resistance, all of these things we need to decentralize. So the first step that we have been discussing across the other full node teams is to move, like I mentioned, move away from feeder gateway dependency. And the way to do that is to have a very basic P2P network where we propagate blocks, transactions, state diffs across all the nodes, where each node can join a P2P network and they can sync the Starknet state from different nodes without having to go through the feeder gateway. That is the initial step. So this is not full decentralization. And then the next step is about, okay, I see it as in three different parts. So first you need to have a leadership election mechanism. You need to have a consensus mechanism, and then you need to also have a free market for provers. So what does each do and what does each provide? So the leadership election mechanism is required for you to decide who is going to be the one to propose a new block. And this needs to be deterministic to avoid a bunch of attacks on the network. So if a node or a peer cannot determine who is the current proposer of the block, they cannot necessarily say anything about the integrity of the block. And so then we have the consensus mechanism. So a distinction to be made here is that this consensus mechanism is an L2 consensus mechanism, where the idea is that we have a network which is creating fast finality, where so users can see what is the head of the chain, they can see what are the transactions that will eventually be proven on L1. So this is to, again, add in terms of increasing TPS and so this is what we'll call L2 finality. And any block that is created via this consensus mechanism will then be passed on to a set of provers. And the responsibility of the provers is then to create a proof that is later submitted into to L1. And then again, we kind of have to worry about having we need to have multiple provers, because if we have only one prover, we end up in the same situation as we are with the current sequencer, where if the prover decides to not submit L1, the proof to L1 at all, they can decide to just not submit a certain block if they so choose. So there needs to be certain incentives in place to allow for that not to happen, and for to ensure that there's constant liveness. And in order to do that, current proposals are to create free market where they can advertise who will be proving the proof, such that if there is someone who is being malicious, they can then they are slashed for doing so. And there's been more details of these proposals that exist on Starknet forum. Yeah.
Yeah, I highly recommend that you read the blog post on the Starknet forum if you want to get into the technical details. One of the big takeaways here is that the sequencer will be closing off access to its RPCs, and everyone, indexers, block explorers, and hobbyists alike, will need to move to full nodes in the not so far future. And this is a very good thing for the network. It'll also improve the sync times because we'll be able to sync from multiple nodes at the same time. And a big part that is coming with this is SnapSync, and the spec of which we've been discussing actually this morning. P2P spec and the SnapSync spec we have been discussing this morning with Starkware, with Pathfinder, Equilibrium Labs, and a few others in a call. Some of these calls are internal, but we are looking to move them to external calls also in the near future as we decentralize, and this discussion needs to be more in the hands of everybody involved in the network.
That's great. It's very positive that you want to involve the communities and the devs, the builders and the users of Starknet. So I'm sure these future community calls will be a success. Anyway, I saw that we had some comments from the listeners. First of all, Crypto Ninja congratulates on you for the speed of the Juno client. And then we have a very interesting question by Becha, who asks, how challenging has it been to develop a full node in an ecosystem that is rapidly evolving? That's the question.
Yeah, that's a great question. I can give a little bit of color on this, and then I might hand over to either Anik or Amir, who are the ones who are hands-on building this node. But there were some struggles at the very early days to understand exactly what the trade-offs were making and what the role of the full nodes would be. The short-term role of these is to give you permission of access to the data. That does not mean that we will be sequencing and creating blocks. We will simply be providing you with the data that you can verify is correct. The second big struggle was constantly changing RPC standards and different parts of the network shifting under our feet, I think. And Anik was involved in the very early write of Juno, which we ended up throwing out and restarting, actually. And this process is why Juno, I think, is so performant now. We learned a lot of lessons at that time. We also got some help from the Nethermind client from the Ethereum side, and a lot of help from the Pathfinder team. But the specific challenges, maybe I will hand over to Anik or Omer if you have any thoughts on this and what the process has been like.
Yeah, sure. So I think everybody recognizes that even Starknet has been improving and learning from what they have been building over time. So we have had to incorporate those changes in Juno as well. So having to make sure that we are compatible with the new version is always quite challenging sometimes, because we have to keep up with, okay, what impact does it have on the data that we have served before? What impact would it have on the new blocks, and whether our RPCs are still going to give consistent information across multiple blocks. And so to give an example, there was a period of time in the early days of blocks where the blocks we cannot compute the block hash. So verifying those blocks are quite difficult. I mean, it's kind of impossible. And we just have to trust the feeder gateway, i.e. the sequencer, to tell us that this block is correct. And we right now assume that the proof that for that block that has been submitted to L1 is correct. And again, this is one of the big reasons why we need to move away from a centralized sequencer and implement decentralized Starknet. So yeah, that's what I had on top of my head. Omer, you can add.
Yeah, along with keeping up with the versions, as the Starknet is gaining more popularity, the rewrite of the VM, performance, the full nodes have been being challenged by the sequencer on how fast they can keep up, how fast they can sync. So you don't get to just implement a new feature that the next Starknet version brings. You have to keep in mind of all the performance implications of the new features as well.
Fair enough, guys. Thanks a lot, first of all, to Crypto Ninja and Beja for interacting with us today. And yeah, Beja, the question was very good. Thanks a lot for that. And well, guys, we've come to the end of this second episode, and it was a pleasure to have you guys. And I must say that I learned a lot from from your talks and explanations around the Juno Starknet client. I got most of it. I would lie if I would say that I understood everything, because it was a bit too technical for me. But still, it was I had an amazing time, and it was very a very learning experience that I really enjoyed. And having said that, I want to remind our listeners that we'll be back on Friday to close this amazing NethermindStark week, and we'll be speaking about educational resources around the Cairo programming language and the latest Cairo 1.0 version of this language, and also about other educational resources to learn to help you out when as you're learning on Starknet. So if you're a dev making your first steps on Starknet and on the Cairo programming language, make sure not to miss our next episode on Friday. So thanks once again to all of you guys who took some of your precious time to be with us today. And a big thank you goes to our guests. Thanks, Yorick. Thanks a lot, Homer. Thanks a lot, Hanek. And obviously, a big hug to all the listeners, Thomas, Antonio, Exodus, Chris, Chi, Shuaigo, Mila, and Beja, Rodrigo, Kodawari, Anelis, Wapnil, Eder.fi, Kobur, Bazat, Crypto Ninja, and Old City. So once again, thanks a lot, Yorick, Homer, Hanek.
Thank you so much, Nev, for having us on again. It's been an absolute pleasure as ever.
Yep, thank you.
And thanks for everyone listening in. Please come catch us on Friday. Annie will be speaking, and he is a very knowledgeable guy on Cairo 1, so he'll probably solve all your Cairo 1 woes and much more there.
Thanks a lot, guys, for the epic episode, I would say. So it's now time to close. Remember to share the Starknet vibe, and see you next time. Bye, guys.
See you soon.
Bye-bye. Take care, everyone.
Bye.